Okay, question 14. A scientist records the velocity, v in meters per second, of a particle from time 0 to time 9 seconds. His results are shown on the graph below. Use the graph to estimate the acceleration of the particle at t equals 1.5. Give your answer to 1 decimal place. Okay, so in order to find the acceleration, what we're going to do is find the gradient at the point t equals 1.5, because that's how we find the acceleration on the velocity time graph. So here's 1.5, there's the point. To find the gradient, then we need to draw a tangent at that point as accurately as we can. Okay. There, I think that's okay. Let's have a look. Yeah, that'll do it. Okay, so there's my tangent, and then I'm going to draw the triangle onto my tangent. So I'm going to draw my triangle's tangent, oh, quite a big one by here. Okay, I'm purposely going for whole lines, you see. So I'm going to draw it here and see what I get. Right, so gradient, M, is the difference in y's over the difference in x's. In other words, it's the height divided by the width. So, difference in y's, well, it's going from 5 to 10, so that's 5. Over the difference in x's, so that's going from 0 to 4, so that's 4. Okay, 5 divided by 4, well, 5 is 5/4, isn't it? So it's 1.25. But we're told to write it in 1 decimal point, so 1.3. Okay, and your numbers might have been slightly different, but you should come out with an answer around about there. Okay, next question. Use the trapezium rule with the ordinates 0, 3, 6 and 9 to estimate the distance a particle travels during the experiment. Okay, so what we're going to do is going to find the area under the curve using an approximation method. So I'm going to put a line here at 3. Okay, I'm going to put another one at 6. Okay, so looking at this then, even though it calls it the trapezium rule, because we're starting at 3, we're actually going to have a triangle to start off with by here to approximate that area. Then we're going to have a trapezium. And then we're going to have another triangle. Okay. And you can see it's not really going to be that accurate because of this. If you wanted to make it more accurate, then you would put more slices in. But you are only going to put the slices where they tell you on the exam paper. So, I'm going to call this shape A. So area A now is going to be, well, it's a triangle, so base times height divided by 2. So the base is 3 and the height is 8. Dividing that by 2, so 3 times 8 is 24, divided by 2 is 12. Area B, there's the trapezium, area B. Again, if you put more slices in, you'd have more trapezium. That's why it's called the trapezium rule. So I've got my trapezium here, and the formula for trapezium, if you don't know it, it's at the front of the paper, half ABH, where A and B are the parallel lines and H is the perpendicular distance in between. So A here, we'll call that A. That's going to be 8, so half 8 plus, I have a parallel line, B, that's going to be 5 times by H, the distance in between, that's going to be 3. Okay, so 8 plus 5 is 13. 13 times 3 is 39. Half of 39 is 19.5. Okay, and now we got area C. So area C equals base times height divided by 2. We've got another triangle. So the base is 3 again. the height is 5 divided by 2, so 3 times 5 is 15, divided by 2 is 7.5. So the total distance travelled now is 12 plus 19.5 plus 7.5. Okay, 19.5 is 20, 27, 29, 39 metres. There we go.